Hello everybody, welcome to my class. So here you can see the topic is vertical circle and the centripetal force associated with this vertical circular motion. So here the objective is to derive equation that describes the amount of kickstart velocity required to complete the whole vertical circle, that is to complete this vertical circular motion. So here we will see that what will be the minimum amount of u so that the object of mass, for example m, completes this vertical circle. So we are going to derive the equation for u so that we will see that that would be the minimum amount of the kickstart velocity that will cause the vertical circle to complete. So let's go further into the process. So here you can see initially the object has been set in equilibrium state, and the velocity given to that object at this point is u. So initial velocity, the start velocity is denoted by here u, initial velocity. So for example, so this is inelastic stream in fact, and of negligible weight, and there is no friction has been considered in this case. So what you can see in this case, weight always acts vertically downward, and hence the tension will be produced in this stream. So the direction of tension about this point, if it pushes down, then the tension direction will be towards this O, where this is going to be act as the center for this circle. So after some times, say the object is at position B, then what happens here at this position? So here in this case also you will see that the weight mg acts vertically downward, although we will see very soon that there will be the component of the weight mg that acts along this center, along or away from the center. So let's consider this as the zero potential position of these objects. That means if the object is, suppose that in fact here we consider it has zero potential energy. Later we will see that this zero potential energy we can consider at this point also, at this point also, any point in the course of this motion. So let's try for the total energy at A and total energy at B. So you know that firstly by the law of conservation of energy, what you can say in this case, the total energy at A equals to total energy at this position. This is P, I think you make it P, at position P. Alright, B is the maximum height in this course of the motion. So suppose that this point as P. So look at here now. So what are the total energy at this point A? We have two kinds of energy. One as the potential energy due to the position of the body. Alright? And the positional distance is here, radius of this circle R. So this is potential energy at A plus kinetic energy at A. Similarly, you can see total energy at P as potential energy at P plus kinetic energy at P. So in order to understand this sort of thing, you first must go through the law of conservation of energy. And now let's go further into that. So what you can see here, potential energy would be what? mg. You know that potential energy equals to mg, or that means the force times the distance traveled. See the work done. So in fact in this case, what you can see here, the force is, only the force is mg, and the distance about which we have considered the potential zero is r. So that will be mg r. So at this point, as body is rising this way, what is happening? Kinetic energy is increasing, then the kinetic energy will be increasing, and hence the potential energy will be decreasing. That means in the course of motion from A to P, every point on this circle, I am talking of this side at this moment, towards the right side, what happens? The amount of potential energy will be converted into the amount of the kinetic energy in the course of motion. It starts from A up to B, we will see. So this is towards the opposite direction, therefore you can say this is minus. Also you can see that this sort of thing is working against of this axis due to gravity, therefore the potential energy value at this point is negative. And kinetic energy, obviously you know that kinetic energy current is also a kind of work done, but the work done due to the motion, and for the potential energy the work done due to the position of the body. So at this point the velocity is u, so you can write here mu square, and then go to the next point here. What will be the potential energy in this case? If you see the potential energy at this point, then you have seen that now the particle is here at this point. That means you have to measure this distance. Okay. So conversely, how we can measure this distance? Just to draw a line parallel to this diameter, for example, it's in 90 degree, and then we have to check what is this distance, because position is at this point means this is at this distance below. So what's the value of d? So here in this triangle, if you see that cos theta equal to the cos theta is adjacent sides by the hypotenuse, that means the base by hypotenuse. So here cos theta equals to b, means what we see here, b is here already, b is d, we have taken b is d, and h is now OP is in fact the radius of this circle, so this is r, therefore d you received at this point is r cos theta. So in that case the distance will be, we have mg, but the distance from this zero potential is d, which is r cos theta. So that is now r cos theta, and this is again below this zero potential line, therefore this should be negative value. And the kinetic energy, now we call the velocity, yes, we are here. Now at this point the velocity is different than the velocity at the initial position. So this velocity is now v, therefore kinetic energy will be now half m v square. Alright? Okay. Now let's go further. And what sort of thing we can see from here, like as we are seeking to find the minimum value of u, we have to go through the condition of this circular motion where the centripetal force and the other forces towards the center or away from the center have significant role over here, therefore we deal through those forces. So before we go further into that, what you can do? Yes. So this is theta, now this is mg, so this mg, you can say horizontal component for mg, this is also theta because these two are parallel, so correspondingly these two angles are equal. So this side you can see the component of this force weight is mg cos theta. Alright? This is mg cos theta and this is t. And there will be another force like this, and this is m. Sorry. It will be mg sine theta. We'll see whether or not we need. We'll use only the things that we need here. Now let's go further. So that here now what our objective is to make the term, you know that the centripetal force equals to mv squared by r, and in this case the centripetal force we have to seek towards center above this point, so that is being given by the force towards the center T, and this is away from the center, means the total amount of force is now mg cos theta, and that is equals to mv squared by r. What I mean is that if we can get mv squared by r from this sort of equation that just now we have found, at that point what we can say, in place of mv squared by r, we can replace this by t minus mg cos theta. So after that it is, so let's make this as subject to mv square, take everything towards another side. So this is now, yes, mv square, so it will come here. So it is now here half mu square, half mu square, then minus mgr is already there, and then if you transpose to the left from this side, and you are writing here this way, so this is mg r cos theta. It's okay? Now our objective is to draw out the term like mv squared by r. So we have to show the algebraic scale firstly in order to get to this sort of term. So here we already have mv squared by r, so just eliminate 2 from all the sides. So this is mv squared equals to, now 2 is cancelled here, so it is mu squared minus, because there is no 1 by 2, so what happens, 2 times 1 by 2, so 1 by 2 is taken out, so it is 2 mgr plus 2 mgr cos theta. Alright, we are very close to this mv squared by r. So now let's divide both sides by r. So what we have right here, mv squared by r equals to mu squared by r minus 2 mgr by r, means you are left with here 2 mg, and then plus is r is also cancelled here, so you are left with here mg cos theta. Alright, and now you see this sort of thing, and you can also see here what can we replace for this sort of thing. We can replace by t minus mg cos theta. Okay, so that means here you have, in this place you can write t minus mg cos theta equals to mu squared by r minus 2 mg plus 2 mg cos theta. Now what happens, let's transpose this part to another and make t as subject. So I am writing the thing that I need to write in the right side, I am going to write in the left side. So what we have in this case, mu squared by r minus 2 mg plus 2, yes. If you transpose this towards the right side, what I am writing from the left here, so it is mg cos theta. Here also you can see plus, and it is minus, so on the side both will be plus. So that's going to be now 3 mg cos theta. So mu squared by r minus 2 mg is here, and 1 mg cos theta and plus 2 mg cos theta is now 3 mg cos theta equals to t. Now let's see. Here in this case, this circular motion is possible only if t is greater than 0 or very close to 0, but t should not be any way less than 0. If the t will be less than 0, there will be no more circular motion. So what should be our assumption in this case is that this t must be greater or equal to 0 in order to complete this vertical circle. That means if you go further after that, what you will find, mu squared by r minus 2 mg plus 3 mg cos theta equal to t greater or equal to 0, means in fact the whole thing is greater or equals to 0. Alright, now we talk about at this point, at B. If you see at B, look at here, this is theta. maybe some degree value it has already. At this point you see that this is making 90 degree. So when it goes another 90 degree, so when this particle is at position B at this point, then what you can say? At position B, what is going to happen for the value of theta? You can see that the value of theta is now 180 degree in this case. So if we are talking of the particle at this position B, in that case, you can see that theta equals to 180 degree. So hence this equation, in this equation we have mu squared by r minus 2mg plus 3mg cos theta, means it is cos 180 degree, which is greater or equals to 0, and you know that cos 180 degree or cos pi radian equals to, that is going to be -1. So if you go further from this part, what you see, mu squared by r minus 2mg, and then it is plus, then this is a minus, then minus plus minus, it is minus 3mg, and cos theta equal to, we have already taken that, it is -1, and this is greater or equals to 0. Now let's solve it further. So it is, you can write mu squared by r, and this is now almost minus 2mg, minus 3mg is minus 5mg. If you transpose all these towards another side, this is greater or equals to now 5mg. Okay? And let's try after. Yes, m and m from both sides, they are cancelled, and you know that m is always here positive. So there will be no change in the inequality sign. That means it is u squared by r is greater or equals to 5g. After this you can see it is u squared is greater or equals to now 5gr. And because here in this case you can see r is positive, g is also positive, and u is just square of the quantity, and we have taken some velocity in the positive sense, that u is also positive, therefore there should be no issue of changing this inequality. So therefore what you can see here, u is greater or equals to 5gr. Alright? So in this case this much meter per second, so value of g will be, value of u will be dependent on, the value of g is constant but r. Alright? So what does it mean? It means that if you go to here, it means that in order to complete or in order to cross this point by the object, the value of u must be greater or equals to minus 5gr. Alright? So if any value less than this will not work for this object in order to complete this vertical circle. So we meet our objective. Okay, we did this proof by taking this as zero potential level, and our result is like this, u greater or equals to 5gr. But we should not, it is not necessary that you extract to a single sort of position. What if your object potential energy at A equal to 0? So you see that this is the zero potential energy level at position A. And then let's see what happens. So in this case, in this case, if you see, look at here, so again you can see by, so this is all for now in fact, but you can see in different ways the same sort of thing. So we can say again that by the law of conservation of energy, what you can say, energy at A equals to total energy at position we have P. But make sure that before This was the potential energy zero level. Now the potential energy zero level is here at this point. So what you see here, this potential energy is definitely going to be zero at this point. But there will be the kinetic energy half mu square. Next, the total energy at P is, you have both potential and kinetic energy. So what you write here, potential energy is mass is mg. Okay, mass is mg, and the distance is now from here, not from here to down, but from here to up. That means in this course of motion up to here, the potential energy is increasing every time. That means potential energy will keep is like positive. And what is the distance? So distance is this sort of thing. You already have whole thing is r. Yes, whole thing is r. And d, you have already seen that r cos theta. R cos theta. Then what would be this height? So from whole r, if you deduct this d, you will have this height. You can say this is d dash. So what you can say here, d dash equals to r minus r cos theta, and in fact that is r1 minus cos theta, or r minus r theta you can use as you see it is easy to you. So in this case, the r will be what? R, or the distance will be r minus r cos theta. So potential energy at P is mg r minus r cos theta. And then we have yes, and kinetic energy is half m. You see the same velocity over here, it is half m v square. Okay, so if you just try to derive from here, you will have the same result as u equals to under the root 5 gr, not equal to, that is greater or equals to this. So your algebraic skill to come to this point, u greater or equal to under root of 5 gr. Alright? Okay, so now I am changing the potential energy position differently. So firstly we took this as the potential energy 0. Next time I took the potential energy here at P is 0. Now what I am going to do is that potential energy is what you call, this is 0. But at this time I am comparing point P and B directly. So while taking this 0, at first I took these 2 points and found u is greater or equals to under root 5 here. Now I am taking the same potential energy 0 at this point, but I am just escaping this point. I am going directly over here saying that velocity is v. Then see what happens to the minimum amount of u. So there must be the same sort of thing, because the method change doesn't mean that the answer changes. That means the root change doesn't mean that the destination changes. So you must have the same sort of thing in each case you see here. Alright. So what I am going to start now as by law of conservation of energy, you can say total energy at A equals to total energy at B. And you already have, for example, this is potential 0 if you are taking is u. So half m u square. And then here on the other side, what can you see? Like half mu square, we have both kinetic energy and potential energy. So let's see what happens at this point. In that case, the potential energy will be 0, but there will be kinetic energy of half m, and the initial velocity here in this case. Here, object is here, so its weight acts vertically down, and also the direction of the tensor will be this. So in this case, your mv square by r will be given by, okay, you'll see that your mv square by r will be given by mg t plus mg in this case. Okay, so let's bear into mind and then let's go further. So it is now here the potential energy, yes, potential energy is mg, and because it is rising up, so potential energy will be positive up to here. Okay, till it gets down from this position, which is not position here, and which is not possible here. So at this point it is mg, and what is the distance? This is r and this is another r. So total distance from this zero potential is 2r. So what we write here? 2r. And kinetic energy, if you are supposing at this point the velocity as v, then that is going to be what? Half mv square. Okay? And then if you would like to go further, what you will see here in this case is that here okay, so firstly half mv square equals to half mu square, and transfer this to the left and the right down here, it is 2mgr. Alright, so remove this 2, then it is mv square equals to mu square minus 2 times 2 is here 4mgr. And then you have mv squared by r required. This is mv squared by r equals to mu squared by r, because we are dividing both sides by r in order to make it free from r. So minus 4mg. Okay. Let's go further in the derivation, and you saw that mv squared by r equals to now t plus mg. So what you can write here at this point, this is t plus mg equals to here mu squared by r minus 4mg. Now let's make u square term as the subject, so that if you keep it here mu squared by r minus 4mg, then you transpose this to there, it is minus mg equals to now t is remained here. So after that we have what we have actually, it is yes. Now you can say this sort of thing is greater or equals to 0 in order to cross this highest point v, there must be t greater or equals to 0. So it is mu squared by r. T greater or equal to 0 means everything you can transpose to us right. So it is minus 4, minus 1, is minus 5. If you transpose to the other side, this is plus 5. So this is plus 5mg, m and m cancel out, positive, they are positive. So u squared is greater or equals to 5gr is remain. All these sort of things are positive. Therefore, what you can write here, you take positive value of u in positive sense. So u is greater or equals to 5gr. In this case as well. So we saw the same sort of thing in 3 ways. You can also think of doing the sort of thing in different way than I explained here for your better practice. Okay guys, so this is all for now. Hope this sort of explanation will help you solve the problem related to the particle circle. So this is all for now, and thank you for your patience.